Continuing with gases, we're going to discuss Boyle's law first, and this is the relationship in a gas between pressure and volume. So definition of Boyle's law states that the pressure of a gas is inversely related to its volume when the temperature and the number of moles of gas are held constant. So this means that if the volume decreases, the pressure is going to increase. Now the pressure of a gas is really related to, let's add this because I think this helps the understanding. The pressure of a gas, is a function of the number of collisions and the strength of those collisions. With a container. Okay, so the idea is that, remember, these particles are moving rapidly in straight lines until they encounter something else. So if I have a certain volume, you're going to have a certain number of collisions. If I decrease that volume, what happens to the number of collisions? Well, the number of collisions should increase because the particles can't travel as far before they hit the container, right? So as the volume decreases, the pressure increases. Okay. So in Boyle's law, the product of the pressure times the volume is constant for a given system as long as the temperature and the number of moles of the gas do not change. And we should have seen this in the lab in class. So you can state Boyle's law as P1V1 is equal to P2V2, meaning the pressure and volume of the gas at condition 1 is equal to the pressure and the volume at condition 2. So that pressure times volume is really equal to a constant for any given system as long as the temperature and the number of moles of gas stays the same. How would we use these? Well, we would use them to solve for one volume or pressure given the other three variables. So say we're given a problem and we're asked for the volume of a gas after the pressure is increased. We would start with Boyle's law and we would solve Boyle's law for the variable that we're looking for. This is an important thing to have in your solution. Is the equation that you used solved for the variable you're looking for in terms of the other variables? It's an important step to include in your work. So if we look at a problem, Freon is used in refrigeration systems. What's the new volume of an 8-liter sample of Freon gas initially at 500 millimeters per mercury after its pressure is changed to 2200 millimeters of mercury at a constant temperature? Setting up your table, what are my starting conditions? My starting pressure is 550 millimeters mercury. My starting volume is 8 liters. My ending pressure is 2200 millimeters, and I don't know what my volume is. You should predict that my volume should be smaller because my pressure increased. It's an inverse relationship, so if the pressure increases, the volume should decrease. Showing the work, solve the equation in terms of V2, plug in the values with their units, and then solve. That is the work that I should see for these types of problems. Right, so, learning check. Pause the screencast while you think about it. And the answer is B and A. Okay, the pressure should decrease in cylinder B and increase in cylinder A. Helium in a cylinder. Again, here's the problem. Pause the screencast. We'll look at the answers in a minute. Answer is 240 milliliters. Okay, again, that's how your work should look. One more learning check. We've got balloons. Pause it. Think about the answer. Here's your answer. Yet another example. Pause it. Answer is 3.2 liters. There's the work. And one more check. Pause the screencast. And the answer is 200 milliliters, or millimeters mercury, sorry, 200 millimeters mercury. All right, moving on. Let's move on to Charles's law. This is the relationship between temperature and volume for a sample of gas at constant pressure. As stated earlier, the Kelvin temperature, you must use the Kelvin temperature. How do I get Kelvin? Well, the temperature in Kelvin is equal to the temperature in Celsius plus 273. Okay. So remember that equation. To calculate the temperature in Kelvin is the temperature in Celsius plus 273. So the Kelvin temperature of a gas is directly related to the volume. So as the temperature increases, the volume should increase as well. Again, pressure and the number of moles of gas are held constant. Why does it make sense that the volume will increase if I hold the pressure and the number of moles constant? As I heat up a sample of gas, what happens to the kinetic energy of that sample? Kinetic energy should increase. So that means that the particles are getting faster. If the particles are getting faster, and if I kept the volume the same, the number of collisions would go up because they're going faster. So to keep that pressure constant, the volume must change so that the pressure remains constant. That's how I view it. All right, so as the temperature goes up, the velocity of those particles increases. If I kept the volume the same, the pressure would go up. So to keep the pressure the same, I have to increase the volume to maintain that constant pressure. All right, so how do we write Charles's law? V1 over T1 is equal to Vt over T2. Now, they solve Charles's law for V2. What I'd like to take a moment is to rewrite it. V1 over T1 is equal to V2 over T2. Let's solve this equation for T2. First, I need to get T2 up top, so I'm going to multiply both sides by T2. T2 cancels. I'm left with T2 times V1 over T1 is equal to V2. Well, I want to get T2 by itself. To get T2 by itself, I'm going to have to multiply both sides by T1. And I'm going to have to divide both sides by V1. The V1 cancels out, the T1s cancel out. Charles's law solved for T2 is T2 is equal to V2 times T1 over V1. Make sure that you can do that. Okay, so solve, oh look, I jumped ahead. There you go. All right, here's a problem using Charles's law. Balloon has a volume of 785 milliliters at 21 degrees Celsius. If the temperature drops to 0 degrees Celsius, what is the new volume of the balloon? In making our data tables, here's condition 1. I start at a volume of 785 milliliters. My starting temperature is 21 degrees Celsius. Cannot use Celsius. Have to add 273 to get it in Kelvin. Condition 2, I have volume 2, that's what I'm looking for. Temperature 2 is 0 degrees Celsius. Can't use Celsius. Have to add 273 to get the Kelvin temperature. Since the temperature decreased, The relationship between volume and temperature is direct, so the volume should be expected to decrease as well. Plugging in the equation, again using those Kelvin, I get 729 milliliters, which did decrease. Okay. Here's another problem for you to try. Pause the screencast. Make sure you use the correct temperature. Your answer should have been 443 Kelvin. Converting that back to Celsius is 170. Now, it's all well and good to compare just two variables, but we can combine Charles and Boyle's law to get what's known as the combined gas law. The Gay-Lussac is in there because N is held constant. So this is still for the same sample of gas. P1 times V1 over T1 is equal to P2 V2 over T2. Again, temperature must be in Kelvin. Yay. Okay. In working problems like this, again, set up your condition 1, set up your condition 2. Fill in what you know for the variables, making sure that you adjust the temperature into Kelvin, and then solve the combined gas law for the unknown variable, and put the numbers in the calculator, solve them. Okay, so looking at that, we would solve the combined gas law. T2 is equal to T1 times P2 times V2 divided by P1 divided by V1. Plugging in the numbers with the units, should have gotten 604 Kelvin, which is 331 degrees Celsius. I'll have you look at one more problem. Pause the screencast, find the answer. The answer is 314 milliliters. And that should end the screencast for Boyles, Charles, and combined gas law.